Okay, this is the mind map for the chapter on speed of reaction. Now, the rate at which a chemical reaction proceeds is called the speed of reaction. So when you see the word the rate, that means how fast it is, okay, or per unit time. That is rate. So speed of reaction is also known as rate of reaction. Now, in general, there are two ways to measure the speed of the reaction. The first one is the change in mass of reactant or the product over time. Okay, the change in mass of the reactant or the product over time. That means how fast the mass of the reactant is produced. I mean, how fast the mass of a reaction of a reactant disappear, or how fast the mass of a product is produced in a reaction. Now, this is the experimental setup to measure the change of mass of the reactants per unit time. So in this reaction, now this is a reaction between dilute hydrochloric acid and marble chip. So marble chip, the chemical formula is calcium carbonate, and of course hydrochloric acid is HCl. So when HCl reacts with hydrochloric acid, and what will happen is HCl, you can actually write down the chemical reaction, the chemical equation, HCl plus calcium carbonate. So this is a carbonate, this is an acid. Acid and carbonate will give you a salt. So in this case is calcium chloride plus carbon dioxide plus water. Okay, then after that you can balance the chemical equation. So this is the balanced chemical equation for the reaction between hydrochloric acid and marble chip or calcium carbonate. So in this reaction, in order to measure the speed, how fast this reaction is, we can measure the mass of the system, the mass of the products, okay, the mass of the reactants or the mass of the products. So in this case, when the products calcium carbonate, carbon dioxide and water are being produced, and the calcium chloride, carbon dioxide and water, and calcium chloride and water would remain in the flask, whereby the carbon dioxide will escape through the cotton wool. Okay, so by measuring the decrease in the mass of this reaction flask, we can actually measure how fast the reaction is. Because if, let's say, the decrease in mass of this reaction flask is very fast, it means that carbon dioxide is produced at a very fast rate, because the carbon dioxide will escape. Okay, which means that the reaction is very fast. Now, if the decrease in mass of this reaction flask is very slow, it means that carbon dioxide is produced at a very slow rate, which means that the reaction is very slow. Okay. And something to take note of is the cotton wool here. Now, the purpose of the cotton wool is to prevent loss of mass due to the acid spray. Now, when the marble chips is first put into the hydrochloric acid, the reaction will start. If there isn't a cotton wool here, because of the vigorous of this reaction is actually very vigorous. So some reactants, and in fact some products, may splash out, and that would result in loss of mass, and that can actually decrease the mass of this, they can actually reduce the mass of this flask. So we do not want any loss of mass due to the acid spray, which can affect the accuracy of the experiment, and that is why we have to always put a cotton wool here. The whole idea is we only allow carbon dioxide to escape through the flask. We do not want other reactants or other products to escape through it. And why is there a thread here? Now, this thread here is so that we can put the test tube into the flask here, and after that stopper the flask with a cotton wool. Then only after that, after we have stuffed a cotton wool at the mouth of the flask, then only we pull the thread here. When we pull the thread here, the test tube containing the marble chips will topple, and that would spill the marble chips out, and the marble chips will come into contact with the hydrochloric acid, and that is where the reaction will start. Now, instead of we pour the marble chips into the hydrochloric acid, if we pour the marble chips into the hydrochloric acid, the reaction will start right away, and we may not have enough time to stuff it with to put the cotton wool in place before the acid spray occur. So that is why we have to stuff it with the cotton wool first, so that the acid spray doesn't occur when the reaction starts. Now let's look at the graph here. In the first minute, now so we can actually plot the mass of the system, which is basically the mass of the flask against time. So in the first minute, what is the average speed of the reaction? First minute means time equal to 0 to time equals to 1, which means that it is from here to here. So we can read the drop, the reduction in the mass. The reduction in the mass is from 60 to 59. So in the first minute, the average speed of the reaction would be 60 gram minus 59 gram over the time. The time would be 1 minute. So this is actually gram, and that would be 1 gram per minute. That is the speed, the average speed of the reaction. Okay? Now we should leave the answer in 3SF. That would be 1.00 gram per minute. That would be the average speed of the reaction in the first minute. Now in the second minute, what would be the average speed of the reaction? So second minute would be from time equal to 1 to time equals to 2. So time equals to 1, the mass of the system is 59. Time equals to 2, the mass of the system would be around 58.4. So that will be 59 minus 58.4 divided by 1. Okay, and that would give you 0.600 gram per minute. Okay, that is in the second minute. How about in the third minute? The third minute, the third minute will be as usual. Okay, now let's look at the third one. The speed of the reaction decreases as time progresses. The reaction stops at. Now, why does the speed of reaction decreases? Now let's look at the graph here. What would be the speed of the reaction? The speed of reaction is denoted, it is represented by the gradient. So you can see that the gradient at the start of the experiment is steeper. Then after that, the gradient will become more and more gentle, and finally it becomes horizontal. When it becomes horizontal, it means that there is no change in the mass of the system, which means that the reaction has stopped. That is why the reaction, the speed of the reaction decreases, because the gradient becomes more and more gentle. As time progresses, the reaction stops. That means what time does it become horizontal? You can actually use your ruler to find out, and actually roughly the curve become horizontal at 8 minutes. Roughly, that would be at 8.00 minute. So at 8 minutes it will become horizontal. You can actually use a ruler to verify that. Alright, so that would be the first one. Speed of reaction is measured by measuring the change in mass of the reactants or products over time taken. So we can actually plot a graph like this, mass of the system against time. And then we can find out at each minute what would be the speed of the reaction. And something to take note, the speed of the reaction is represented by the gradient of the curve. And when the gradient becomes 0, okay, this part of the gradient actually becomes 0, or when the graph becomes horizontal, that is when the reaction stops. Okay, Now, the second way to measure the speed of the reaction is to measure the volume of gas produced. Measure the volume of gas produced. So, for example, same thing. You have hydrochloric acid here. You have magnesium ribbon. So this magnesium is a metal. Hydrochloric acid is an acid. So let's write down the chemical equation: HCl plus Mg. So what would be the product? You have a metal with an acid. Acid and metal, you get salt, MgCl2 plus hydrogen gas. Then after that, you can balance the chemical equation. So we can measure the volume of gas produced. We cannot measure the mass of the product. In this case, MgCl2 is quite difficult. So let's look at the setup here. So same thing, the test tube containing the magnesium, it is being tied to a thread, to a string. Okay, once we have, okay, so the first thing that we need to do is to lower the test tube to the flask containing the hydrochloric acid. Then after that, we stopper it with a delivery tube, and the delivery tube is connected to a gas syringe. Okay, then when this setup is firm, when we have completed this setup, in order to start the experiment, all we need to do is to pull the thread. When we pull the thread, the test tube will topple. When the test tube is toppled, the magnesium inside will come into contact with hydrochloric acid, and that is when the reaction starts. Now, so the purpose of the thread is to topple the test tube containing magnesium ribbon after the flask is stoppered. It is to prevent loss of mass due to the escape of hydrogen gas. We want to measure the volume of hydrogen gas. That is why we cannot afford to for any hydrogen gas to be lost, because we want all this hydrogen gas to go into the gas syringe. Okay, and of course, when we topple the flask, when we topple the test tube containing the magnesium ribbon, that is when we start the stopwatch. Okay, so we can measure the volume of the hydrogen gas collected here against the time, and after that we can plot the graph. So this is the graph. So in the first minute, same thing. In the first minute, how much hydrogen is produced? In the first minute, that would be from time equal to 0 to time equals to 1. That will be about 17 cm cube. 17.0 cm cube of hydrogen is produced. Then after that, between the first and the second minute, second minute 25 cm cube, first minute 17. So between first and second minute, there will be 25 minus 17. That would be 8 cm cube. Alright, so the reactions last for how long? This is the point whereby the reaction stops, when the gradient of the graph becomes 0 or when it becomes horizontal. So the reaction lasted for how long? The reaction actually lasted for 4.5 minutes. 4.5 minutes. In total, how much hydrogen is being produced? In total, 35 cm cube hydrogen is being produced. Now the speed of the reaction at the third minute mark is faster or slower than the reaction at the first minute. Then in order to find out how fast the reaction is, we look at the gradient. At the first minute mark, this gradient, okay, at the third minute mark, there will be this gradient. So which one is steeper? This one is obviously steeper. Okay, so at the third minute mark, that would be slower, the speed of the reaction, than the speed of the reaction at the first minute mark. So remember, in order to find out how fast the reaction is, we have to look at the gradient of the graph. If the gradient is very steep, it means that the reaction is fast. If the gradient is gentle, it means that the reaction is slow. Okay, chemical reaction occurs. So far we look at two methods to measure the speed of a reaction. Now is we would like to find out how a reaction occurs. So in order to understand how a reaction occurs, we have to look at the particles of the reactants. Now reaction occurs only if reacting particles collide with each other. So collide is the keyword. You don't say reacting particles hit each other. That would not be accepted. You have to use the keyword collide. So reacting particles, reacting particles collide with each other. Reacting particles possess a minimum amount of energy or activation energy. When particles possessing activation energy collide, effective collision are resulted and the product is formed. Now, for example, when you put two reactants together, okay, they will collide. But not all collisions will result in product being formed. Only when the reactants possess enough energy, and then they collide, then the products will be formed. For example, this one, there are two types, there are two reactants here. So they collide. You can see the results of the collision. Only this product is formed. These two, they are the reactant, they are the original reactants. No products are formed. Which means that out of these two collisions here, there are two collisions. Out of these two collisions, one of them, the reactants possess enough energy that results in these products being formed. The other collisions, the reactants don't have enough energy. That is why they just collide, they bounce off each other, they remain as the reactants. Now, an example of this would be car collisions. Okay, there are two types of car collision, touch wood. There are two types of car collision. The first type, the car collide at a very high speed with enough energy. So fatalities are resulted. People die. And the second type of collision, the energy, that means they collide with a slower speed. They collide with a slower speed, which means that they don't have enough energy when they collide. And that is why for such collision, no fatalities are resulted. So it's the same thing. So when the reacting particles have enough energy and then they collide, then the products will be formed. Fatalities would be resulted. When the two reactants, they don't have enough energy, they collide, then no products will be formed. No fatalities will be resulted. So not every time whereby when you put two reactants together, there will be products formed. Okay, and products will only be formed when the reacting particles have enough energy and then they collide. So the amount of energy, the minimum amount of energy, that is called activation energy. So activation energy is what? The definition of activation energy, which is something that you have to remember, is the minimum amount of energy that reacting particles must possess in order for a chemical reaction to occur. When a chemical reaction occurs, that means product is being formed. Now, what if the reacting particles possess energy more than the activation energy? Same thing, products will be formed. So they must, the reacting particles must possess this minimum amount of energy called activation energy in order for products to be formed, in order for chemical reaction to occur. Okay, the page 2 of the mind map concerns factors that affect the speed of the reaction. Now, a lot of times we want to find out how do we speed up the speed of a chemical reaction. For example, you set up a factory and this particular factory produce detergent, for example. Of course, your goal is to earn as much money as possible by producing as many detergent as possible. So you have to find out how do I make the what do I need to do in order to make sure that the production of detergent is very fast. How do I increase the speed of the production of detergent? So that is why in this page of the mind map, we look at what do we need to do in order to make a reaction faster. So there are many things. There are 5 things that we can do in order, 4 or 5 things that we can do in order to make a reaction faster. The first one is by increase the concentration of the reactants. Okay, so we can make a reaction faster by increasing the concentration of the reactants. So what happens is, for example, in this case, you have concentrated solution, you have diluted solution. So diluted solution, it has 1, 2, 3, 4, 5 particles of reactants A. And for concentrated solution, you have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 particles of reactants of reactant A. So concentrated solution, basically at the particle level, it means that there will be more reacting particles per unit volume. Okay, more reacting particles. It is not just more reacting particles. It must be per unit volume. We have to fix the volume. We cannot compare concentration by not fixing the value. By not fixing the volume. We can only compare the concentration of 2 solutions by making sure that these 2 solutions have the same volume. Okay? So more reacting particles per unit volume. When there are more reacting particles per unit volume, there will definitely be more collisions. When there are more cars in the highway, there will definitely be more collisions. Touch wood again. So more collisions means that there will be more effective collisions. More collisions on the highway, there will definitely be more fatal collisions. Unfortunately, it works in that way. And when there are more effective collisions means collisions that will result in product being formed. So more effective collisions per unit time, it means more products. It means that products are formed faster, and it means that the speed of reaction is faster. Okay, so this part is basically to list down all the key points. Okay, if the question asks you, explain from the particle point of view why the speed of reaction can be increased, or why the speed of reaction increase by increasing the concentration of the reactants. This is how you have to explain step by step. First of all, explain what is the meaning of higher concentration. It means more reacting particles per unit volume. When there are more collision particles, it means more collisions, which means more effective collisions, and the reaction can be formed faster, hence faster speed of reaction. Now, how about the second one, increasing the speed? So, a second way, second thing that we can do in order to make the reaction faster is by increasing the speed of is by increasing the temperature of the reactants. Because a lot of times when we heat the reaction mixture, the reaction will be faster. Okay, heat the reaction mixture is actually equivalent to increasing the temperature. Okay, so the second one, increasing the temperature of the reactants. Higher temperature means the reaction particles have more kinetic energy. More kinetic energy, of course, it means more collisions. More collision, of course, it means more effective collisions. Reactions are formed faster and faster speed of reaction. Okay.